Welcome back. So in this portion, we want to start out by talking about how we've taken this input and now we're going to start doing some processing to it. One of the more common things that we do with input is we perform calculations on it. So let's talk a little bit about that. We can do math on our pieces of data. We can perform calculations and give a value. The math operator, which is a tool for performing calculations, and operands, which are values surrounding the operator. Variables can be used as operands, and oftentimes are. The resulting value typically is assigned to a variable. Just to kind of jump in a little bit, we've got two types of division. The single slash operator performs a floating point division, while two slashes operates the operator performs integer division. Positive results truncated, negative rounded away from zero. So again, if we're doing integer division and the results have a decimal in it, anything on the decimal is truncated. If it's a negative number, then it's rounded away from zero. Just like in math, we do have a precedence to our operators, and we can group with parentheses. So the Python operator precedence is operations enclosed in parentheses is always number one, which forces operations to be performed before others. Then exponential, which is these 2 stars. Multiplication, which is 1 star. Division, both single and double slash. And remainder. This, by the way, oftentimes is known as modulus. But it's remainder math. And then finally, additions and subtraction. The higher the precedence, the first it will be performed. So again, first, second, third, and fourth. Same precedence operators execute from left to right. So we got left to right. Let's talk about that a little bit. So with that being said, let's talk about exponential. If we want to say 2 to the third power, then we would say 2 star star 3. And that's 2 to the third power. However, we want to just multiply 2 by 3. Then we only have to have 1 star. Okay? Modulus, or remainder, gives us the remainder after division. So let's say we say 2, or excuse me, let's say we say 10 modulus 2. What's going to happen is it's going to take 2, it's going to divide it into our number, which happens to be 5, and that means there's no remainder. So the answer to this is 0. 5, it goes into 10, 2 goes into 10 5 times with no remainder. Well, what if you were to say 11 modulus 2? Well, 2 into 11 goes 5 times with a remainder of 1. So the answer to this is 1. I know, you're like, okay, Professor Waits, why would we ever do that? What's the point of getting what the remainder is? I'm glad you asked. Oftentimes, we utilize modulus or the remainder to find out if something is even or odd. If we want to know if something is even, my var, we want to know if it's even or odd, we can always modulus by 2. And if the answer is 0, then we know it's even. If the answer is 1, we know it's odd. Always. Well, that's pretty cool. Anything else? Yeah, another very common reason we use modulus is to keep a number within a set of numbers. So let's say I wanted to uh, uh, get a number that is like a roll of a dice. So we're doing a random. We're going to do a random number, which is going to create a random number, but we want to put it within, let's say, like a dice, 1 to 6. Well, let's say our number is, again, my var. My var happens to be this random number, and we want to keep it between 1 and 6. Well, just so you know, most programming languages, their numbering system starts with 0. Python does as well. So, in fact, we don't want to say 6 as our remainder number, because if the number came up as 6, excuse me, let me try that again. We want to put our remainder percentage, our remainder number by 6. So what's going to happen is it's going to take whatever my var is and divide it by 6. So whatever my var is, we're going to divide it by 6. And whatever comes out as the remainder is going to be the answer. Now, because we're doing remainder 6 as our operator, the answer has to be 0 through 5. Because let's say, and let's figure that out. So let's say my var is 1. So it would go 0 times with a remainder of 1. Agreed? What if it's 2? Well, same thing. Our answer is going to be a remainder of 2, and so forth. So 3 is now going to be 3. But eventually we're going to get to 6. And what we do is we get an answer, but our remainder now goes to 0. 5 is 5. So 6 is always going to create 0 through 5. Well, how do we ever then get that dice roll of 6? Well, we don't have a die of 0. So what we can do is whatever comes out of this, we can just add 1 to it. And that will shift the answer over by 1, right? So let's see what that looks like. So we say my var modulus 6. It's going to always return a number at 0 to 5, but we want our number to be 1 through 6. So let's say we take my var modulus and we just assign it to die, right? And then we would, to get that 1 through 6 now, don't be difficult. Don't be difficult. We say die equals and let's make it dice plus 1. So this takes that 0 to 5, always adds 1 to it, so now it's 1 to 6, and whatever that is, puts it back in dice. So if we needed a number, let's say 1 to 10. Well, if we want 1 to 10, then we say, and that will give us 0 to 9, which we can add 1 to it, and now we have 1 to 10. If we use parentheses in our math, so we already know if we have 2 times 3 plus 6, written this way, 2 and 3 will get done first, and then whatever is the results of that will be added to 6, right? Well, what if we add a parentheses here? Then what happens is this will get done, and then whatever the answer is to this will get multiplied by 2. Because the parentheses changes the precedence, because we always do operations enclosed in parentheses first. The exponents operator and the remainder operator, we really did work through this already, so we don't have to spend too much time on this page, but this says x to the y power. And the remainder operator performs division and returns the remainder. This is that modulus operator that we keep talking about. So because we're using 2 here, remember what we said before, this is the way we find out if a number is odd or even. And because it's 2, we're always going to get either back a 0 or 1. 0 is even and 1 is odd. All right, let's take a break from this, and we'll come back and we'll jump in to some more math, converting math formulas to programming statements. See you shortly.